Gutom ka, full trip ta.
May hapon mga kaedukasyon, kumusta ka mong tanan? I hope naa ka mo sa kapisgay sa maayong panglawas. Karong hapon na natay duha ka lesson para sa atong bag-ong mga episode sa ALS Bridging Camp. Of course, magapasalamat ako sa mga taga-subaybay nato nga permanenteng gapananaw. Mapasalamaton ako sa tanan kaninyong gapananaw. Of course, may due respect to my Schools Division Superintendent, Ma'am Cherry Limbaco. Sa akong Assistant Schools Division Superintendent, Ma'am Weng, hello sa mga kapananaw diha. Sa akong Chief, Ma'am Lori, Sir Sally Vitorilio sa SGUD. Mga kaedukasyon, nakita ninyo nga nag-jacket ako sa Department of Education. Ug ang ilawom naka-blue ug naka-Superman. Alang kini sa atong 123 kakasalugan sa pagkamugna sa Departamento sa Edukasyon. Alang kini sa mga magtutudlo nga ilawom silang mga sanina, mga Superman kitang tanan. Kay gihimo nato sobra pa ug more than beyond what is necessary for us to be able to deliver our lesson. So karong hapon na tan-aw nato ang duha ka episode ug makapaminaw kitang tanan sa mga ginikanan diha og mga learners. Welcome and please keep watching.
Happy Thursday, everyone! Welcome again to ALS Bridging Camp. We are on our 4th episode. Today, we shall be learning about calculating the measures of central tendency of ungrouped and grouped data. Watch and learn today's episode with Teacher Beverly Ann.
Good day, learners! Welcome to Mathematics 7. This is your teacher, Teacher Ann, and today's episode is all about determining the measures of central tendency for ungrouped and grouped data.
At the end of this lesson, you are expected to solve problems involving measures of central tendency for ungrouped and grouped data.
Statistics is a branch of mathematics that deals with the organization, presentation, analysis, and interpretation of data. For this particular episode, we will focus on data analysis, particularly on measuring central tendency of a set of data.
Analyzing data gathered to obtain useful information is one of the important things a statistician does. Determining the central tendency locations are one of the important aspects of doing data analysis, and there are three averages involved on it: the mean, the median, and the mode.
These three measures of central tendency will be explored deeper as we go further with our discussion. And to start with, let's try to understand the concept of these three averages for ungrouped data.
This is the first example we will deal with. As you can see, we have here the list of weekly savings of 10 students. From this ungrouped data, we will calculate the mean, median, and mode of this set of data. We will calculate the mean first. Our working formula will be this. The mean usually uses an X bar symbol. So instead of writing the word mean, you may use the symbol to pertain about the value of a mean of any given set of data. This symbol pertains to scores, while this symbol pertains to the sum of scores. And we read this as the summation of x sub I divided by n, where n pertains to the total frequency. Now, performing the process of getting the mean, we add all the scores, that is, 60 plus 50 plus 40 plus 50 plus 70 plus 50 and plus 50 plus 80 plus 70 and plus 70. And this is divided by 10 since we have 10 scores here. Of course, we cannot proceed to division unless we know what is the final answer on our numerator. So, we need to get the sum of the scores first, and that is 590. So, 590 divided by 10 is 59. Therefore, on the average, these 10 students can have a weekly savings of more or less 59 pesos. Next, we solve for the median. The median is the middle value of the set of data after it has been arranged in either ascending or descending order. Ascending order means i-arrange ang scores gikan sa kinagamyan paingon sa kinadak-an. And descending order means ang bali. I-arrange gikan sa kinadak-an paingon sa kinagamyan. Pili lang ka kung asa ang dali buhaton para sa imo because it will still give you the same answer as long as it is properly arranged. Now, there are two cases to consider. When n is even and when n is odd. In this particular example, since we have 10 scores, we have n as even. So let's start by arranging the scores first. What I did here is arrange the set of data in ascending order. Gikan sa kinagamyan, paingon sa kinadak-an. Since our n is even, we have two middle values to consider. This is always true when n is even. But pasabot, pag ang n is even, naagyud tay duha ka middle values. From the two middle values, we will get the mean. That is why we solve 50 plus 60 divided by 2. 50 plus 60 is 110. And 110 divided by 2 is 55. Thus, the median of this set of data is 55. This time, let's have an example that has an n which is odd. So, from the previous 10 scores, let's eliminate the last one and so we have 9 scores instead. Always remember, the first thing to do is to make it sure that the data has been arranged properly before you proceed to solving the median. Again, this time, I arrange it in ascending order. Since our n is odd, we only have one middle value. Always. Kay naaman kay 9 ka scores, this means ang tunga, which is ang ikalima nga score, ang atuang median. So, this means from the set of data, our median score is 50. We are done getting the median, so the next measure we are going to solve is the mode. Mode is the value that occurs most often in a given set of data. Organizing data is always important whenever we do calculations. That is why, if you can recall in statistics, there is a process that we follow. Organize the data, present the data, analyze the data, and interpret the data. In this particular discussion, we have been focusing on data analysis. But then again, data organization will be significant as we go along this discussion. So, I will introduce to you one of the two ways of organizing data. Some of you may have come across this way of data organization since it must be a prior knowledge for this topic, but some of you may have not. So nevertheless, for the benefit of everybody, one way to organize data is by using a frequency table. As you can see, the first column of the table shows the amount which is not written repeatedly. Since on the next column, the frequency is where you have to account how many times the amount or score occurs. Understanding the table, the amount 40 occurred once, while the amount 50 occurred 4 times, 60 once, 70 3 times, and 80 once. So, sa frequency, ang buhaton is ihapon pila ka buok sa kada score ang naa and mauna ang ibutang. Another way of organizing data is the stem leaf plot. In this example, the stems are the digits on the hundreds place and the leaves are the digit on the ones place. Basically, 40 can be written like this in a stem leaf plot. And if your data is 4 50s, it can also be written like this. So going back to the task of getting the mode, using the frequency table, the one that has the highest frequency is the mode, and so that is 50. Looking on the stem leaf plot, the one that has the longest leaves will be the mode, and likewise it is 50. Is it possible to have more than one mode? Yes, it is possible. Because take note, mode is a value that occurs most often. So it is possible that one or more values can occur most often in a given set of data.
Tatlong bagsak para sa ating lahat. At this point, you already have learned how to calculate measures of central tendency for ungrouped data. Did you find it easy? Sure you did! At this point, we will apply what we have learned on this particular task.
The mean for this particular set of data is 11. Add all the scores and divide it by 9, you will get a mean of 11. For the median, as we know, we have to arrange first either ascending or descending order. And as always, I prefer to do the ascending arrangement. But then you can do the descending since it will just give you the same answer. Since we have 9 scores, then after arranging, we know that the 5th score is the median, and that will be 11. Finally, getting the mode, since we have already arranged the data, it will now be very easy to know who among the scores occurred most often. In this case, we see that 11 occurred thrice among others, and thus the mode is 11. As you can see in this particular task, we can also say that there are cases that the mean, median, and mode will also be equal.
Good job, learners! Now, we are ready to go further with our discussion. At this point, we will now learn how to calculate measures of central tendency for group data.
This time, we will solve the 3 averages of group data. In a group data, you can always see class intervals. To get the mean of the group data is equals to the summation of f times x divided by n, where f is the frequency, x the midpoint, and n sum of frequency. For us to complete the task, we need to solve the midpoint of every class interval. So let's start from this class interval. To get the midpoint is getting the sum of the 2 values divided by 2. That is, 28 plus 29 divided by 2 is equals to 57 divided by 2, and this is equals to 28.5. Next interval, we have 26 plus 27 divided by 2, and this is 53 divided by 2, and the answer is 26.5. Going to the next interval, we have 24 plus 25 divided by 2, which is equals to 49 divided by 2, and is equals to 24.5. Now, the pattern is obviously seen. So we know that midpoint of the next interval is 22.5 since there is a difference from one midpoint to the next. And so 22.5 will be followed by 20.5, followed by 18.5, and so on. So we have completed the table at this point by solving all the midpoint values of every interval. Next, we need to solve what is fx, which is the product of f and x in every interval. To make our data more organized, let's add another column on our table which will show the value of fx in every class interval. So, we start from the uppermost class interval, and this will be the product of 1 and 28.5, and the answer is 28.5. Next interval, we have 3 times 26.5, and the answer is 79.5. This time we cannot see a pattern because frequency of every class interval may come in different values. To continue, we have 3 times 24.5 which is equals to 73.5. 3 times 22.5 is 67.5. 6 times 20.5 is 123. 6 times 18.5 is 111. 8 times 16.5 is 132. 6 times 14.5 is 87. 10 times 12.5 is 125. And finally, 14 times 10.5 is 147. Now we have completed the table and all the necessary calculations have been done for us to compute the mean. First, we get the sum of the product of frequency and midpoint for every class interval and divided it to the sum of frequency, which is 60. Now the sum of all the product of frequency and midpoint is 974, and we divide it to 60 to get a mean of 16.23. After calculating the mean, we will now find the median. In getting the median, we need to compute the cumulative frequency, which we use the symbol CF. Let me show you how the cumulative value is computed in every interval. We can start from the bottom class interval, and since it is the bottom, we simply copy its frequency as its cumulative frequency. Now we move upward one step at a time. That is, from 14, we add the next frequency of the next class interval, which is 10, and so the cumulative frequency will now be 24. Then 24 will be added to 6, so the next cumulative frequency is 30. 30 is added to 8, and so we have 38. 38 added to 6 to arrive to 44. And continue the process to arrive to the uppermost class interval, in which the cumulative frequency must be equal to n, which is 60. At this point, we can actually compute what is n divided by 2. Since n is the total number of values, and that will be 60, so we have 60 divided by 2, and that is 30. It is from this value that all the remaining values involved in getting the median will be determined. Gikan ani nga computation, magbase ang uban nga variable sa atong working formula. Next, we need to determine the L, the lower class boundary containing the median. Since L involves getting a lower class boundary, our table, as you can see, have added one more column to compute the class boundary of each class interval. We need to take note of these considerations when we are computing class boundaries. When values or scores of a given set of data are whole numbers, we will have to add and deduct 0.5, such that if one of the value is 12, then plus minus 0.5 will be done. However, if the scores or values involve decimal numbers, then the following considerations must be noted. If decimal values are in tens place like 2.1, then it must be plus minus 0.05. If it is in hundreds place like 2.12, then it must be plus minus 0.005. If it is in the thousands place like 2.123, then it must be plus minus 0.0005 and so on. Kay whole numbers man ang atuang class interval, then ang atuang gamiton in calculating the class boundaries is 0.5. On this side of the class intervals is where we get the lower class boundary. And to get the lower class boundary, we have to deduct 0.5 on each. While this side is where we get the upper class boundary, and we add 0.5 on each. So, let's start from the bottom class interval. From 10, 0.5 will be deducted, and from 11, 0.5 will be added. And so, the class boundary will then be 9.5 to 11.5. Going upward from 12 minus 0.5, and from 13, 0.5 will be added. So, the class boundary will be 11.5 to 13.5. Next, we have 14 minus 0.5 and 15 plus 0.5. And the class boundary will be 13.5 to 15.5. 16 minus 0.5 and 17 plus 0.5, which will have a class boundary of 15.5 to 17.5. And do the same to the rest. Thus, we have 17.5 to 19.5, next 19.5 to 21.5, 21.5 to 23.5, 23.5 to 25.5, 25.5 to 27.5, and finally, we have 27.5 to 29.5. Now, we have completed our class boundaries. Going back, L as defined is the lower class boundary containing the median. Please take note that this is where lower class boundaries belong, while these are the upper class boundaries. Now, since our median is contained on this cumulative frequency, the lower class boundary on this level must be the L, that is, the L is 13.5. Now, how about the B, which is the cumulative frequency of the group before the median group? If the cumulative frequency of the median group is 30, then before 30 is 24. So, the B value is 24 then. After knowing the B value, let's proceed getting the F, the frequency of the median group. Again, the median group falls in the cumulative frequency of 30. So, the frequency beside it will be the F value, and that is 6. Finally, let's compute the W or the group width. W or group width is actually the difference of any of these values. You can also get the W from this side as well. And the answer will still be the same. So, for this particular example, I will just choose 13 minus 11, and the answer is 2. This means our W for this set of data is 2. Now we are ready to compute the median by substituting the values we have computed. And so we have median is equals to 13.5 plus the quantity of 30 minus 24 divided by 6 times 2. In simplifying, we start with the parentheses. And since we cannot divide yet unless we know the difference of 30 and 24, so we start from there and the answer is 6. Thus, the equation now will become 13.5 plus the quantity of 6 divided by 6 times 2. Next, we divide, and 6 divided by 6 is 1. And so the equation now is 13.5 plus 1 times 2. Based from the order of operation, we have to multiply first 1 and 2, and the product is 2, which will be added to 13.5, and thus the median then is 15.5. So we are now on the part which the mode of the group data will be computed. We will just be using the previous table, but basically, the cumulative frequency CF is not anymore needed in solving the mode. This will be the working formula of getting the mode of group data. The first thing we have to figure out is this symbol, F sub M, which is the frequency of the modal group. This is actually the class interval that has the highest frequency, and that will be 14. So F sub M is 14. Next, we locate the L. The same as the median, L is the lower class boundary of the modal group. Since our modal group is located at frequency 14, then the class boundary beside it, which is 9.5, will be the value of L. Then next, the symbol F sub M minus 1, which means the frequency before the modal group. From 14, which is the frequency of the modal group, we should go down since it is before. But since wala na may frequency ubos sa 14, kay of course, ang frequency nga 14 ang naa sa pinakaubos, this means then that F sub M minus 1 is equals to 0. The next symbol, F sub M plus 1, which means the frequency after the modal group. So from 14, we go up. frequency nga ibabaw sa 14, and that would be 10. And finally, W, the group width, which we have already computed, is 2. Now, we have identified every important value for us to be able to solve mode. So, we now substitute it. Mode is equal to 9.5 plus the quantity of 14 minus 0 divided by 14 minus 0 plus 14 minus 10 times 2. Again, we solve first the parentheses. So, the equation will be equals to 9.5 plus the quantity of 14 divided by 14 plus 4 multiplied to 2. Solving 14 plus 4, we have 9.5 plus the quantity of 14 divided by 18 and times 2. And 14 divided by 18 is equals to 0.78, and multiplying it to 2 is equals to 9.5 plus 1.56, which will give us the mode value of 11.06.
How did you find our lesson? Indeed, it's very interesting to learn the different ways of calculating the mean, the median, and the mode for ungrouped and group data. But, nevertheless, these concepts are both very important to us humans. At this point, I will leave you a task for you to be able to apply the concepts of calculating the measures of central tendency for group data. Answers will already be provided. So your task is to figure out how to arrive to those given answers. How was the activity? I'm sure you are excited to apply what you have already learned. Always remember that in getting the measure of central tendency of either ungrouped or grouped data, there are three averages that are involved: the mean, the median, and the mode. Congratulations, learners! You have completed this lesson. Let's see each other on our next episode as we go deeper in learning Mathematics 7. This has been your teacher, Teacher Ann, wishing you a wonderful day ahead. God bless and keep safe.
That ends our 4th episode. We would like to thank again and again Teacher Beverly Ann of Mambuaya National High School. To everyone, thank you for being with us in this episode. We continue to do this for all of you, our ALS learners. If you have comments, words of support, and appreciation or clarifications of Teacher Beverly Ann's lesson, you may write them at the comment section below.
So mga kaedukasyon, bali kita human na ning mga pipila ka pahinumdom. So
sa panahon ngayon, ano na nga ba ang pangako?
Ito ang walang kinikilalang layo o hadlang para sa mga mahal ko sa buhay.
Ito ang paggarantisa na tuloy ang aral, trabaho at negosyo para sa lahat.
Ito ang pagkalinga sa kabataan upang mapagpatuloy nila ang pag-abot sa mga pangarap. Magbago man ang panahon, hahanap tayo ng pagkakataon.
Pagbuhos ito ng alaga at atensyon sa mga lugar na kailangan ng tulong at suporta.
Ito yung patuloy na paghanap ng paraan at paggawa ng diskarte para sa kabubuti ng lahat.
Pagiging pamilya siya sa mga taong pinakamalapit at malapit sa iyo.
Pagiging nanay ko ito sa mga tinuturing ko na ding mga anak.
Sa bawat luto at hain ko, nasasabi ko nandito ako para sa kanila.
Bilang panganay, likas na sa akin ang pagiging maalaga, kaya manong na rin ang tawag nila sa akin dito.
Part ito ng pagiging world class, ngayong Global Filipino Talent, hindi lang para sa iba, pero para sa atin din.
Ito ang paghatid ng ginhawa at aruga sa mga taong may mahal din sa buhay tulad ko.
Abilidad itong makita ang sarili sa gitna ng lahat at masabing nasa tamang lugar ako at ginagawa ko ang lahat.
Ito ang diwa ng Ayala. Ang pangakong walang kinikilalang layo o hadlang. Ang pagmamalasakit sa pamilya, sa komunidad, at sa bayan. Pagtanaw at paglikha ng oportunidad para sa lahat. Noon hanggang ngayon, ito ang aming tugon.
Maayong hapon sa tanan. Welcome to the 5th episode of the ALS Bridging Camp. Today's learning episode is about performing operations on rational algebraic expressions. To all our audience, watch and learn from Teacher Rubinet from East 2 of the Alternative Learning System.
Good day, learners! Welcome to ALS Bridging Camp. This is our 5th episode of the Bridging Camp. I am your teacher, Ruby. I will be your grade 8 mathematics teacher. Let's enjoy and have some fun. Our topic for today is about operations on rational algebraic expressions, specifically on addition and subtraction. Our learning objectives for the day is that the learner is expected to perform the operations on algebraic expressions, specifically on addition and subtraction. But before we proceed to our topic, let's have first an activity. And we call this activity as approved or disapproved. The mechanics of this activity is just simple. We approve if the answer is correct, and we disapprove if the given answer is wrong.
Let's now begin with our activity, and it is about addition and subtraction of fractions. Our first category is about approve or disapprove using addition of fraction. Number 1, 3/5 plus 1/5 equals 4 over 10. Is it approved or disapproved? Number 2. 2/5 plus 1/3 equals 11 over 15. Is it approved or disapproved? The next category is about finding the difference of fraction. Number 2. 5/6 minus 3/6 equals 1/3. Is it approved or disapproved? And number 4. 2/3 minus 1/2 is equal to 1/6. Is it approved or disapproved? I will give you 30 seconds to answer the following question. Okay, so I guess you have already done answering all the questions. Now, let us check all your answers. Number 1. 3/5 plus 1/5 equals 4 over 10. The correct answer is, it's disapproved. Why? Because the correct answer is 4 over 5. Number 2. 2/5 plus 1/3 equals 11 over 15. The answer is approved. Therefore, it is the correct answer. Number 3. 5/6 minus 3/6 equals 1/3. The answer is approved. Again, it is the correct answer. And number 4. 2/3 minus 1/2 is equal to 1/6. The answer is approved. It is the correct answer. I hope you have gotten all the correct answers. If you do so, our activity is about adding similar and dissimilar fractions. So what is the connection of our activity to our topic? Let me elaborate to you what is a fraction and algebraic rational expression. A fraction is a ratio of two numbers where the denominator is not equal to 0. Example, we have 2/3. While rational algebraic expression is also a ratio of two polynomials where the denominator is not equal to 0. Example, x minus 1 over x plus 3. As you can see, both of them, the fraction and rational algebraic expression, is common on ratio. Both of them are ratios wherein the denominator should not be equal to 0. Therefore, when we do addition and subtraction of similar and dissimilar fraction or rational algebraic expression, they have the same process. So now, let us begin our topic. Let us start in addition and subtraction of similar rational algebraic expressions. But first, let me define what is a rational algebraic expression that is similar. Two rational algebraic expressions are said to be similar if both expressions have the same denominator. Example, we have 2x over x minus 3 and 4 over x minus 3. As we can see, they have common denominator, which is x minus 3. Therefore, they are similar rational algebraic expressions. Now, how do we add or subtract similar rational algebraic expression? In adding or subtracting similar rational algebraic expressions, we do the following steps. Number 1, simply add or subtract the numerators. Number 2, write the sum or difference in the numerator over the common denominator. And simplify if needed. Example number 1. 6 over x minus 3 plus 2 over x minus 3. So as we can see, both rational algebraic expressions have the same denominator. So they are called similar rational algebraic expressions. So now, we then proceed to the process or step-by-step procedure. The first one is to simply add or subtract the numerators. So the numerators are 6 and 2. Therefore, we add 6 plus 2 and write the common denominator, which is x minus 3. So, we then simply add, the result is equal to 8 over x minus 3. Since this is already simplified, this is the final answer. Example number 2. Let's have subtraction. X squared plus 3x plus 2 over x squared minus 2x plus 1 minus 3x plus 3 over x squared minus 2x plus 1. As we can see, they are similar rational algebraic expressions. Why? Because they have the same denominator, which is the x squared minus 2x plus 1. So then, we follow the steps in adding or subtracting similar rational algebraic expression. So before it, we need to identify first the parts of the subtraction. The first expression is what we call the minimum. The second one is what we call the subtrahend. It is very important to identify both because we need them in subtracting the two similar rational algebraic expressions. The first step is simply copy the numerator of the minimum. And the next one, we subtract the numerator of the subtrahend. So that becomes x squared plus 3x plus 2 minus the minimum, which is 3x plus 3. And then, we copy the common denominator, which is x squared minus 2x plus 1. After then, we will simply multiply the subtrahend numerator by negative 1. So since the subtrahend is 3x plus 3, so the result now in multiplying negative 1 is negative 3x minus 3. So now our new numerator becomes x squared plus 3x plus 2 minus 3x minus 3 over x squared minus 2x plus 1. After then, we group together similar terms. So as we can see, similar terms are those with the same variables. So we combine or group together those with x variable and those without variables. So we have x squared group positive 3x minus 3x and group also positive 2 minus 3. After then, we add the similar terms. So we add positive 3x minus 3x and we also add positive 2 minus negative 3. So the result in adding the similar terms, we have 0 for positive 3x minus 3x and negative 1 for positive 2 minus 3. So our new numerator now is equal to x squared plus 0 plus negative 1 over the denominator, which is x squared minus 2x plus 1. Then, we simplify. So, since the middle term is 0, we omit the middle term. So, the result now becomes x squared minus 1 all over x squared minus 2x plus 1. As we can see, this rational algebraic expression can still be simplified. But how do we simplify? In simplifying the rational algebraic expression, we find the factors of the numerator and the denominator. So the factors of the numerator, which is x squared minus 1, is equal to x plus 1 times x minus 1. This is what we call the difference of two squares in the factoring. And in the denominator, x squared minus 2x plus 1 is equal to x minus 1 times x minus 1. And we call this perfect square trinomial. So since we have both the factors of the numerator and denominator, we then replace the numerator and denominator with its factors. So now, the numerator becomes x plus 1 times x minus 1 over the denominator, which is x minus 1 times x minus 1. Then we simply divide the numerator and denominator with a common factor. So their common factor is x minus 1. So when we divide it, it becomes 1. So after then, we then multiply the resulting value to x plus 1 over x minus 1 times 1. And after then, the final result would be x plus 1 over x minus 1. So since this is already the simplified 1, therefore, this is the final answer. So since we are done in the addition and subtraction of similar rational algebraic expressions, let's now proceed in addition and subtraction of the similar rational algebraic expression. But first, let us define what is the similar rational algebraic expression. It is two rational algebraic expressions that are said to be similar if the expressions have different denominators. Example, x squared minus 2x over x minus 3 and 4x plus 1 over 5x plus 2. As we can see, both the rational algebraic expressions have different denominators, which is x minus 3 and 5x plus 2. Therefore, they are called dissimilar rational algebraic expression. How do we add or subtract dissimilar rational algebraic expression? In adding or subtracting dissimilar rational algebraic expressions, let's follow some steps. The first one is we need to find the least common denominator or the LCD. Number 2, we rewrite the equivalent rational expressions with the LCD as the denominator. And next, add or subtract the equivalent rational expressions, and then we simplify if needed. So let's have some examples. Example number 1. 6 over x plus 3 plus 2 over x minus 5. As we can see, both of the rational expressions have different denominators, which is x plus 3 and x minus 5. So then, the first thing we need to do is we find the least common denominator, which is simply x plus 3 and x minus 5. After then, we rewrite the denominators using the LCD. So both of the expressions will now have the denominator, which is x plus 3 times x minus 5. Then, we multiply the numerator with the quotient of the LCD and given denominator. And how do we do this? So we have LCD divided by the given denominator, which is x plus 3. So as we can see, in dividing the LCD x plus 3 and x minus 5 with the given denominator x plus 3, we have a common factor, which is x plus 3. So that becomes 1. So the resulting quotient is x minus 5. Then, we just simply multiply the numerator with the quotient x minus 5. So that becomes 6 times x minus 5. Then we proceed to the second expression. So still the same, LCD divided by the given denominator, which is x minus 5. And then, as we can see, in dividing the LCD x plus 3 times x minus 5 with the given denominator x minus 5, we found a common factor, which is x minus 5. So then, this becomes 1. So we multiply it to x plus 3. The result still is x plus 3. After then, we multiply the numerator with the quotient x plus 3. So now the numerator becomes 2 times x plus 3. After then, we add the numerator over the LCD. So we have already the rational expression, which is equal to 6 times x minus 5 plus 2 times x plus 3 over the LCD, which is x plus 3 times x minus 5. After then, we now multiply 6 and 2 using distribution method. So the result would be 6 times x minus 6 times 5 plus 2 times x plus 2 times 3 over x plus 3 times x minus 5. Then, we just simplify. 6 times x equals 6x minus 6 times 5 equals 30 plus 2 times x equals 2x and plus 2 times 3 equals 6 all over x plus 3 times x minus 5. In adding similar terms, we have 6x plus 2x and negative 30 plus 6. We have the result in adding the similar term 6x plus 2x is equal to 8x. While in adding negative 30 plus 6, the answer is negative 24 over x plus 3 times x minus 5. So then we simplify 8x minus 24. Since if we multiply positive 1 to negative 24, the result is negative 24 all over x plus 3 times x minus 5. Since there is no common factor between the numerator and the denominator, this is now the final answer. So let's proceed to the second example. Example number 2, we have 6 over x plus 3 minus 2 over x minus 5. So as we can see, I have chosen the same given in the example number 1, but this time we are using subtraction to identify their difference. So since, again, both of them are dissimilar rational algebraic expression, we do the following. First, we find the least common denominator, which is still the x plus 3 times x minus 5. Then again, we rewrite the denominator using the LCD, which is x plus 3 times x minus 5. But this time, we are going to use subtraction. Next, we multiply the numerator with the quotient of the LCD and the given denominator. Still the same process. So here we have x plus 3 times x minus 5, which is the LCD, all over the given denominator, which is x plus 3. So since we have a common factor, which is x plus 3, so therefore that becomes 1. Then we multiply it to x minus 5. The quotient is x minus 5. After then, we multiply x minus 5 to the numerator. That becomes 6 times x minus 5. The second rational expression, still we have the LCD divided by the given denominator, which is x minus 5, and the common factor is x minus 5, which becomes positive 1, and then we multiply it to x plus 3. The result would be x plus 3. And then we multiply the numerator with the quotient, which is x plus 3. So that becomes 2 times x plus 3. So now we have the new numerator, which is equal to 6 times x minus 5 over x plus 3 times x minus 5 minus 2 times x plus 3 over x plus 3 times x minus 5. As we see, we already used subtraction. Then, we distribute 6 and negative 2 this time using distribution method. In the first example, in addition, we distribute positive 2 since it is addition. But this time, we use negative 2 in distribution since we have negative or minus 2. So, we will now have 6 times x minus 6 times 5 minus 2 times x minus 2 times 3 over x plus 3 times x minus 5. Then we will have the result. So 6 times x is 6x minus 6 times 5 is equal to 30 minus 2 times x is equal to 2x minus 2 times 3 is equal to 6. So now our numerator becomes 6x minus 30 minus 2x minus 6 over x plus 3 times x minus 5. As we can see, we have similar terms, which is 6x and negative 2x, which has the same variable x. And we have negative 30 and negative 6, which has no variable. So we simply add those similar terms. And the result would be 6x minus or plus negative 2x. The answer is positive 4x plus negative 30 plus negative 6, that becomes negative 36 all over x plus 3 times x minus 5. So now, to simplify, we just simply have 4x minus 36, which means positive 1 times negative 36. That becomes negative 36 all over x plus 3 times x minus 5. As we can see, there is no common factor between the numerator and the denominator. Therefore, this is already the final answer. Thank you for watching the first episode and continue learning grade 8 mathematics.
Did you learn something today? I hope so. This is once again your teacher Ruby na nagsasabing pag may natutunan, may magandang kinabukasan. See you next time! Bye-bye!
Daghang kaayong salamat, Teacher Rubineth, for sharing your time and expertise for our ALS graduates and learners. To all our audience, thank you so much for being with us today in our learning episode. We are doing all this for all of you, our learners. If you have clarifications for Teacher Rubineth, comments, message of support, or appreciation, you may write them in the comment section below. Kita na sa taugma, diri lang sa ALS Bridging Camp at 2:30 to 3 o'clock in the afternoon. Again, ALS Bridging Camp.
So mga kaedukasyon, nakita ninyo ug nahuman ninyo og ayo ang atong mga episode. Ug I hope na amoy nasabtan. Hangtod sa sunod Huwebes dinhilang gyapon sa Aksyon Edukasyon atong pagatan-ahon ang laing episodes sa ALS Bridging Program. So mapasalamaton usab ako sa mga tawo nga naa sa studio. Kay Sir Mark, kay Sir Justin, of course among creative director si Doc January Balinsona, ang among technical director si Sir Ray Maghoyo, and of course ang among President and CEO si Sir Dante Sudaria, and ang among Vice President si Doc Rose Sudaria. Hangtod sa sunod Huwebes, alas 4 paingon sa alas 5 sa kahaponon dinhilang. So, bye-bye!
Mindanao daily, Mindanao daily, Mindanao daily, Mindanao daily, Mindanao daily, Mindanao daily. Watch out! natin ang inamigo ay paglugad. Laag Divisoria, uban ng higala ay nakatingala. Sana nagdiri Mindanao Daily, Mindanao Daily, Mindanao Daily, Mindanao Daily, Mindanao Daily, Mindanao Daily.
Kontreta, pag humantan na sa kumbera, bisag asa, panalugara, agrikultura, pasiuda.
Wow, Mindanao, nakapost sa social media. Local artist, MDN, mong suporta. Saktot mga old and new na sonata. The local scene, urban city, Bandukada.
Mindanao Daily, Mindanao Daily.
So mga kaedukasyon,